Good morning, good afternoon, and welcome. I'm very pleased to be joined by Birgitte Bak-Jensen. Birgitte is a professor of intelligent control and on power distribution systems at the Aalborg University in Denmark. And Birgitte is going to be speaking at the Powergrid Leaders Conference, 12th, 13th of March in the Netherlands. So welcome, Birgitte. Thank you very much for joining me.
Thank you. I'm happy
You're
to be here.
obviously, yeah. So you're obviously I guess quite a technical hat in terms of studying intelligent control and power distribution systems. But obviously we've just been speaking, previously, and it obviously encompasses a lot more issues around beyond technology, obviously around system design and how you design a future sustainable energy system that helps accelerate change and can encourage sort of behaviors. So what are some of your sort of opening thoughts around technology and the business models and flexibility? Essentially, we're trying to design a more flexible system. We've got new technologies coming on, so there's a lot of I guess considerations that have to be taken around private use, energy clusters, energy communities, industry. What are some of your opening thoughts about the challenges that the new technologies will present?
Yes, our main technology is focusing on providing flexibility to the electrical grid, and that is both for the overall balancing, but also to enhance the capacity of the distribution grid. But there is a lot of things that actually interfere or set up some borders that we have to adapt to be able to do that. And one of them is, of course, all the regulation that we have on the things that we are doing. So we have to put up our technology in relation to the actual regulations, but sometimes also we actually try to push to the policymakers to change some of the regulations. So they, for instance, it's only during the recent years we have the possibility to form energy clusters or energy communities. And what we do within these energy communities is to try to optimize both the services that we can give to the grid, but at the same time taking into account user comfort and user uh, uh, engagement in being able to actually fulfill our technical solution or think that our technical solution is a good way. So, for instance, these energy losses can go together, making an aggregated value to the flexibility market or to the energy market, and then get a better cost or benefit for themselves by providing a maximum capacity limit to the grid or giving the flexibility at the right hours for the overall balancing. But at the same time, making the control in an intelligent way so they don't go too much on compromise on their own comfort, and
Mm.
to also ensure that if they have their own PV systems, or then they have as much self-supply as possible. So we are controlling it both to try to satisfy the customers, but also the grid owners and the overall balancing of the system.
Yeah. I guess it's around that word optimization. So trying to make sure that you're, designing the least cost overall system for everyone. And I guess that question of everyone is a balance between what the DSOs can get back in terms of a return on their investment, but equally the private customers and indeed, I guess,
Yeah, and that
in
is no matter
clusters.
if it's a private customer or it's an industry, because you cannot in the future probably have that all customers, for instance, if it's a private living area, that all customers charge their EV cars at the same time, because that would overload the grid capacity. And of course, then it's a compromise, because then all customers cannot get the exact time slot where it is fully the cheapest one, but seen as a social community, then we can average for everyone so they in total get the best price in total and have electricity all time because they are not overloading at 4 o'clock when everybody return from home and plug in the car.
Yeah, that makes a lot of sense. I mean, it makes a lot of sense, but I assume it's quite complicated to actually get right. And what are some of the, and how do you get there? And what are some of the stages that you see in terms of, I guess,
Of course,
what do you
we
need to,
offer.
yeah,
Sorry.
sorry, go
We
on.
we offer the technical solutions to try to do that, but we have to do it in close cooperation with the customers. So we get their point of view for how they can be able to provide the service that we expect. So it's not that we are developing a technical solution and then just push it onto their head, but we develop it in cooperation and get their input before we make the final setup for the solution. And it's also quite a lot about getting the information to the customers. Why is it actually needed that you no longer can just use the electricity as you want? Because in previous time, at least in Europe, it was very easy. The electricity was always there, and you can just plug in whatever you would like. But now, with these very high-intensive energy-consuming units, that is actually not possible. So if you have to have a community which is based on this, they have to understand also what are the main idea of why they should actually go into this service. Can get a better price because we try to control it so they charge when the price is minimum, and if they have a battery we use that first and so on to get an optimized cost for them as well. Then there is of course an incentive in an economic way, but we also actually try to explain them the more uh, reason for why they have to do it, and then we help them making the automation, because nobody are able to control all the devices according to an app if they have to do it manually. So this is also what we can offer, and tell them that we can help with this solution. And that is again, no matter if it is a private household or it's an industry.
Yeah. I mean, and have you got any sort of specific examples? I mean, I know, smart charging but within that sort of smart charging framework, the grid can draw, I don't know, is it 20% maximum off your car battery yeah, what are some of the real life practical implementations
The real practical implementation is that we make forecast of what they normally use for car charging, for heat pumps and whatever, and then we are scheduling these. So, of course, if they want their car to be charged at 7 o'clock in the morning, we will make the optimized scheduling according to the grid's conditions and the prices and so on. So this is what we do. And if they have a heat pump at the same time, okay, we take that into account. We take the battery into account if they have such as well. And the same for industry. We look into the different processes which are possible to shift in time, and then try to pump a lot of water for a place when the electricity is cheap, and the same with cooling houses and so on. We maybe decrease the temperature with 1 extra degree, so they have this as a kind of storage for later on. So this is how we do it. system conditions into account, because also you cannot freeze things too much, because then you damage some of the things. So you have some limits that you have to be within, and this has to be, of course, discussed with the customers so we can set up their preferences and their conditions, but at the same time we can help them minimizing their cost for electricity.
And in order to do that, there obviously has to be a sort of base amount of technology that is at both the premises of the private customer or the company, and vice versa. Is that is there a need for certain standards, or also around the actual, I guess, sensors and technology and
Yeah, of course, the people we have been involved with are doing the actual setup. They are, of course, adapt to different standards, and also, for instance, for controlling the cars, we have had a lot of issues because they have different standards for the different cars, and then making a kind of similar solution which can adapt to all cars has not really been possible. But now we have at least a bunch of 7, 8 different cars where we can do it.
Right. Okay. And in terms of the whereabouts are we in the development of an intelligent clean energy system, and how do we evolve there? I assume it's it's experimentation, feedback, experimentation, a process of development.
But we have a lot of demonstration sites now, also in a lot of different countries, because actually we are cooperating in some high level projects on EU level.
Mm-hmm.
So we have demonstration cases in many countries, and they the companies which are involved are now going into the commercialization process for the control devices and so on. So we are close to having a solution which can be spread out to, let's say, private households, and next step would be also to go more into the control for industries. We are maybe a little behind there, but we will
Yeah.
make, use more or less the same principle, but it's different applications. So you always have to figure out how are the loading. It's always about providing flexibility and shifting the load, but it's a question from the different kind of industries. What can they actually be flexible on, as well as it is for the private customer?
Yeah, no, that makes a lot of sense. So, is there a time scale for a sort of first phase rollout, or a trial, or?
Yeah, as some of the project is running now, and there is a product which is sold, for instance, in Denmark, in relation to this private household, and we have also some large battery management system which are developed in Poland now, which are running. So there is a rollout here, and so the next step is, of course, to get more abilities and so on. And one of the next step in Denmark, for instance, will be also to apply the system for what we call terminets, because mostly it has been individual heat pumps and EV systems and so on. But in Denmark, and maybe also in Germany and other countries, they are now talking about making small areas in local villages heated by what they call thermonet. Instead of having a full district heating, thermonet is running only with 30, 40 degrees heat, and getting that from a common brine.
Yeah,
So then you control the heat pumps which are attached to this thermonet as a cluster. So the same method. The next step is now to try to use it in these as well.
that's fascinating. So everyone's individual heat pump are contributing to a collected source of brine solution that's connecting different houses, the Thermonet.
Yeah.
Fascinating stuff. Well, it's been fascinating to talk to you. Lots happening. Very exciting. Certainly a key area in terms of making sure that the technologies can help us optimize and ultimately create, a low cost energy system where we get electricity, heat, mobility, at the lowest cost price. And we clearly have, I guess, the technologies. I guess it really is around that sort of systems design and implementing it. So it's great to chat to you, Birgit. We're looking forward to seeing the development of the projects you're working on, and indeed hearing you and meeting you face to face come 12th and 13th of March in the Netherlands. So many thanks for taking the time out to speak to me today.
Thank you very much. I look forward to have the meeting as well.
Cheers. Bye-bye.
Yeah. Bye.